Welcome to this month's FDTD Satellite Applications webinar. Today, we're very pleased to have Nathan Marsili from the National Weather Service Forecast Office in Northern Indiana. The topic today is the December 30th, 2017 Mesovortex in the Great Lakes. Next slide, please. This is an ongoing series of webinars. The URL for the webinars is within that blue box. Dan and I'm Scott Lindstrom. Dan Bikos and I at CIRA, we are always looking for speakers. So if you have a topic on which satellite information has given you useful information, please contact us and we'll help you figure out how to give a presentation. Next slide, please. Just some logistics on the next slide. I'm not seeing the next slide, but I'll speak to it. Don't press hold. There'll be about 20 minutes for the speaker, followed by Q&A. You can also enter in questions via the chat. And with that, let's hand it over to Nathan. Take it away. Thanks.
Thanks, Scott. Just want to make sure you can see the first overview slide to make sure it's still forwarding.
Yes, I can see it.
Okay, great. All right, thanks, Scott. I'm just going to go over today an event which is about 3 years ago to the date here, a Mesovortex which affected Lake Superior and pretty much went down the length of Lake Michigan and affected our forecast area in northern Indiana on New Year's Eve. So just a general overview here. We're going to be talking about the general setup leading up to this Mesovortex, several smaller scale mesovortices over Lake Superior on the 29th, and eventually you had that larger scale mesovortex develop on the 30th across southern Lake Superior, and it really wreaked havoc as it moved inland there, just east of Marquette, but Marquette, Michigan got in on the very strong westerly winds on the backside of that meso low on the 30th, and it caused 40 to 60 mile-an-hour wind gusts and bands of heavy snow and blizzard conditions at times in the UP of Michigan, and several reports of water spouts also. Then as that mesovortex moved inland, it really got reinvigorated as it moved over north central Lake Michigan and persisted down the length of the lake, and as I mentioned, produced the heavy snow and gusts to around 40 miles per hour in our forecast area and created a 20-car pileup on the interstate there. So we're just going to look at what are some of the factors that could have been responsible for the mesovortex formation and evolution, and how can we anticipate these in an operational environment. So just to get a large-scale perspective of the whole event here, just the radar mosaic here, evolution, you can see it starting off with this mesovortex moving inland just east of Marquette. Then that, as I mentioned, it got reinvigorated by renewed convection in north central Lake Michigan. And it's kind of hard to see, but that mesovortex over Lake Michigan pretty much hugged the coastline down the eastern shore with a dominant single band in its wake, as you can see in the mosaic there. So just a quick synoptic overview. These plots here from the December 29th 12Z period. So we're looking about 24 to 30 hours before landfall there east of Marquette. At 700 millibars, you can pick out that very elongated, negatively tilted mid-level trough there. But the big thing is just pointing out the very cold core of this Arctic air mass was about to drop southward here over the northern Great Lakes, minus 30 RAOB data there, and near James Bay, minus 27. So that was one ingredient. We really needed that very deep instability with this cold core dropping southward. Then at 9:25, you can see that the similar view of that Arctic air mass, minus 20 temperature there at 9:25 across much of the southern Ontario area. And then this warm anomaly over north central Lake Superior, where lake aggregate low and trough had developed over north central Lake Superior. And at the surface, you can pick out this surface trough pretty much over Lake Superior also, with its warm core origins there. And this feature had been semi-permanent in the previous few days, pretty much the 27th, 28th, and 29th, just this stalled out surface trough kind of marking that interface of the Arctic air mass. So this is the morning, the day before the larger mesovortex moved inland. This is just the channel 13 clean IR window here. Just going to loop this and point out a few features here. The forecasters at Marquette noted these several smaller circulations here over the open waters, one with this mid-lake kind of convergent boundary. You can kind of see a smaller scale mesovortex in the south central part of the lake. And then over the western Lake Superior, another mesovortex in there. But what I want to draw your attention to is on the eastern part of the lake, those cloud streets with that strong southeast flow or moderately strong southeast flow on the east side of that aggregate low pressure system, kind of feeding into the north part of the lake here. And you had onshore flow in northern Lake Superior, north of that aggregate trough. So you can just see how this setup was favorable for a prolonged period of convection across north central Lake Superior. And these brightness temperatures here are anywhere from -35 to -45 Celsius. So just indicating the amount of instability we had over Lake Superior. And I think a big component of this was just the longevity of this convection, which I think played some role in creating the larger scale mesovortex as it dropped southward. We'll kind of talk about it with this diabatic PV anomaly that developed in response to that prolonged convection. So then taking a look at some of the other tools we have with GOES here, the water vapor bands, showing the channel 8, 9, and 10 here. And just remembering as we have that ability with the low level water vapor, 7.34 micrometer, to look at the weighting functions based lower in the atmosphere here. So you can see how that weighting function, you can get a view of the lower level features, which we're probably more interested in for this particular setup, given it's more of a shallow warm core process occurring. And here's an example of the channel 9 and 10 band. On the left is the mid-level water vapor band, and channel 10 on the right, low-level vapor band. And you can just see that through inspection of this loop here, you can get a sense it's just to the broad developing cyclonic circulation here. And this, I think it's maybe indicating this developing diabatic PV anomaly too, in addition to the synoptic tendency for this, this cyclonic rotation here. But you really can see that evidence of that perturbation a little better here in the low-level water vapor, where you get those stronger gradients of low-level moisture with that lower weighting function that we saw, lower based weighting function there. So this is this previous loop we looked at here. This is from the evening before the mesovortex moved inland, and so this is the 6Z. So we're looking about 12 hours before the mesovortex moved inland. Very deep instability. This is a RAP analysis from 6Z, just indicating lake-induced capes here of about 800 to 1,000, and you can see the lake-induced equilibrium levels up to about 17,000. Just a very deep, unstable layer here, which doesn't, it's not a big surprise. That was really what this mesovortex really fed off of to a large degree. Now we're looking at the time period where the mesovortex moved inland, where the morning of the 30th here from 12 to 16Z. Just going to play this through here, and you can see almost two individual circulations here in the clean IR channel 13. You can almost see one circulation developing, dropping, kind of highlight this here, over the south central part of the lake there, and then another circulation, kind of, you can see it more just dropping east of Marquette. Very strong gradients in the brightness temperature here, and that's kind of interesting to see with that eastern mesovort. You almost can see that the circulation develops in this stronger substance area with the compensating substance with the convection, probably just a testament to the warm core influence of it, with the hydrostatic influence of that substance causing the circulation on that eastern mesovortex there. But I think these two circulations eventually merged near the shoreline and moving inland to form that one mesovortex, those two individual mesovortices. So I'm going to just go over some of the lake conditions here. This is the Great Lake Surface Environmental Analysis here for lake temperatures from December 29th, 2017. Nothing really shocking in terms of lake temperatures. We were in that +3 to +6 range over Lake Superior. Pretty much the same thing, a little warmer over Lake Michigan. Pretty seasonal for the time here. This is the 2017 is in cyan, and we're in late December here. So you can see we're pretty much falling right in the middle of the previous 6 years of lake temperatures. So that wasn't really the anomalous part of the lake temperatures. It was really just the magnitude of that Arctic air mass, which increased these fluxes from the lake. Now, I think it's interesting, kind of before going in a little further on this event, just to compare to some of the more extreme cases of mesovortices over the Great Lakes. And this was a study by Greg Mann and others here with Hurricane Huron in September 1996. And this was probably one of the extreme cases where it was a transition of an extratropical cyclone to a more of a warm core tropical characteristics here over Lake Huron. You can see it has a well-defined eye and spiral bands, much like a tropical system. And in their study, they found the sensible and latent heat fluxes from the lake were on the order of 700 during the peak of the event. Where that blue line denotes the max fluxes, 700 watts per meter squared combined fluxes. So and they noted in this study that compares to some of the fluxes you get in the wintertime when you get these Arctic intrusions over the warmer lakes. So it seems like when we get into this fluxes towards 700 watts per meter squared, that's when we start to get these favorable environments for these mesovortices. And so just running some estimated calculations for this event using some observational data that we had in place and making best guess fields based on the data we had. These are some of the fluxes we were calculating for this event, which based on different wind thresholds, you can see when we got into that 20 to 25 knot range, we were talking about fluxes of 600 to 700 watts per meter squared. So that put it on par with that September 1996 event in terms of the fluxes from the lake. So one of the things with this event was that one of the remarkable things was that it was really well handled from a numerical modeling perspective, even 2 and 3 days before the event. So thought since it was had the ability to be simulated, it would be a good idea to try to use local modeling and specifically the WRF UEMS to try to recreate a successful simulation to see what might have been going on. Try to assess the contributions from the fluxes from the lake and see what level of importance they had in comparison to maybe latent heat release with the convection that we saw for a prolonged period in north central Lake Superior. So we know that factors that will affect mesovortex development is that convergence of land breezes. You kind of get this convergent flow in these bowl-shaped areas on the shorelines that can help generate vorticity, which can lead to vortex stretching and create these mesovortices. Frictional convergence, as we mentioned, latent and sensible heat fluxes. And then one thing which I was kind of most interested in going this event to look at was the contribution of latent heat release with the actual convection to see how that compared in relative contribution to the fluxes from the lake. So to attack this, we just used the WRF UEMS and developed 3 different runs for a sensitivity experiment, one using full physics, then one turning off no latent heat release, and then one turning off the fluxes from the lake. And so all 3 of these runs were initialized at 12:29:0 which is about 38 to 40 hours before that Marquette landfall there. So just some basic parameters here from the full physics run, and we're looking at forecast hours 31 to 42. You can see how things evolved here. Did a pretty good job capturing the overall evolution of the event with these stronger winds coming around on that west side of the mesolow there. The actual model simulation did shift it a little further west than it actually moved inland. So that was one error in the simulation, but I think overall it captured the general processes going on that created this evolution here. So here's a comparison of all three runs, just showing that basic sea level pressure and 10-meter wind, just showing how they compare for no latent heat release and turning off the lake fluxes here. And the big thing that jumps out when running this as it makes landfall there in southern Lake Superior is just the how the no flux run starts off with a closed circulation there, but it just rapidly decays that low, turning off the flux, which isn't really a surprise. I think it's pretty well documented that the lake fluxes are of first order importance to the mesovortex development. But on the left here, it's kind of interesting. The no latent heat release run does have a decent pressure minimum. If you compare it to the full physics run in the top right there, it is about 2 to 3 millibars weaker with the no latent heat release. So I found it interesting that turning off latent heat release, it's not a trivial impact. You do lose quite a bit of strength of the mesovortex there, and you can see, especially on the northern flank of this mesovortex, the winds are much stronger in the full physics run on the north shore there compared to the no latent heat release. And I think that was just a case of being in proximity to that diabatic PV anomaly across the north. It just wasn't there by turning off the latent heat release, so you lost that contribution there. So here's just a graphical view of the further three sensitivity runs, the sea level pressure minimums through time. Landfall, again, pretty much in that forecast hour 38 period. The first 24 hours of these trends are more related to just the lake aggregate trough sea level pressure minimum, and then later on more of the mesovortex. But you can see the largest differences between these runs with the full physics is with the no flux runs. During the peak strength there at forecast hour 33, you can see that turning off the flux accounts for about 5 to 6 millibars of the strength of the low. And then no latent heat release accounts for, as we mentioned, about 2 to 3 millibars difference there. So in trying to think of what was going on in this case, I kind of went back to the old the PV thinking analysis, how typically we would think of a PV anomaly in the upper levels of the atmosphere, and how you can amplify it downstream, have that upper level cyclonic circulation communicated to the lower levels, inducing a cyclonic circulation beneath that anomaly, which would amplify a thermal ridge, which in itself, a thermal ridge can be thought of as a surface PV anomaly, and that would have a circulation communicated back upward in that smaller, the thinner cyclonic circulation, and amplify the upper PV anomaly. So you get this self-development type process occur. And what the governing factors to how effectively these circulations are communicated in the vertical through previous studies have shown that it's related to static stability in that layer, more instability, better communication, and the magnitude of the anomaly and the orientation of the anomaly are important also. Now, in this particular case, we're not really looking at upper levels being of first order importance. It was more, warm core, low level features going on. So I think in this case, we were looking at a diabatic PV anomaly, which was represented in this conceptual model here of a warm core anomaly in the low levels with the diabatic heating. You kind of get your isentropes bend downward to compensate for that warm anomaly. And that PV anomaly from the diabatic heating induces a cyclonic circulation in the low levels there. Very analogous to the upper levels, just we're looking at kind of the interior layer of the atmosphere. So in our full physics run of the one of those three in the sensitivity study, just plotted here the 900 to 850 potential vorticity in units of PVU from pretty much a lot of the cycle from forecast 18 to 48, just showing the PV in this layer. These greens and yellows indicate positive anomalies of 1 to 2 PVU. And you can kind of see two areas I want to point out here is just over the central part of the lake with that mid-lake convergence where you had prolonged convection and diabatic heating with the latent heat release. And then on the northern part of the lake, where that convection was most sustained, you can kind of see this diabatic PV anomaly take shape here. So we'll just kind of run this through the evolution. You can see that that northern Lake Superior diabatic anomaly in that 900 to 850 layer just dropped southward and almost become like a vortex ring there in the southern part of the lake and merge with the PV anomaly with the mid-lake convergence there. So we'll just run this one more time and kind of show, this kind of reinforces that idea that we, in the satellite imagery, we saw those two separate circulations, and I think that's related to those two different diabatic PV anomalies kind of merging together as they drop southward there. So as we mentioned before, one of the interesting aspects of this event was that the Mesovortex survived pretty much the inland track into north central Lake Michigan, where it became reinvigorated. So we just ran a second set of those 3 runs to a shorter 24-hour run from 0Z the 31st to 0Z January 1st to see how those fluxes measured in relative importance with the latent heat release for the Lake Michigan portion of the event. And here you can see, starting off here, we're starting out about 18Z on the 30th here with this shortwave IR imagery, just showing how the Mesovortex right in the Marquette vicinity made it survived into the north part of Lake Michigan there. And you can see toward the end of this loop, we get some re-intensification of the convection over north central Lake Michigan. And really this mesovort, as I mentioned, just tended to follow down the eastern shoreline there as it dropped southward. Let's run this one more time here. I think it was hard to trace, from a satellite perspective until the convection really flared up again. Then it became a much sharper feature once again. So it's hard to know, was it maybe this land breeze convergence which re-intensified things, or was it just the actual latent heat release from the convection re-intensifying things? And here's just a quick view of as that feature got to southern Lake Michigan, comparing the full physics run with the no latent heat release run. You can see one of the things that really stands out is that with it turning off latent heat release, that surface trough just quickly plows through southern Lake Michigan, not even really a closed circulation with turning latent heat release off. It's more of just a surface trough, whereas the full physics run had a longer duration over the lake and a much stronger feature, and stronger northwest winds in the wake of that surface low with it. And turning off the flux from Lake Michigan, the background pressures with the no flux are even higher. But I think what's interesting is even with just turning off the flux from Lake Michigan, you still can get a sense there's a little circulation there on the eastern shore, which wasn't visible by turning off latent heat release. So I think that's a testament to the role of latent heat release in the latter parts of this event in maintaining that circulation over Lake Michigan for a longer period. So here's a visible image from courtesy of SIMS as the Mesovortex moved inland here. You can see pretty much approaching the Benton Harbor area, highlighting the warm core nature of it, 20 degrees there, which it's pretty unfortunate that's considered the warm core, but that's what we have here. And but the area of impact really is not the actual where the mesolow tracks. It's usually this band of intense single band lake effect snow on the backs in the wake of it that's really the impactful part of it. And this was interesting because we had a forecaster at our office who spent a lot of time studying these. Him and Lashley and Hitchcock termed type 6 lake effect snow events, which were analogous to a typical mesovortex event, except they formed with usually stronger flow over Lake Michigan. And it was really a different class. None of the previous 5 types of lake effect snows captured it. So they suspected these land breeze convergences intensified these mesovortices, but a little different than the typical mesovortex generation, that you had stronger flow. And here's on the right there, a visible image of one of their cases, which looks very similar to the current case we're dealing with. So it fit nicely into this type 6 regime from Lashley and Hitchcock there. So as with Lake Superior, both the fluxes from the lake and latent heat release played a crucial role. But we talked about maybe the importance of that latent heat release over southern Lake Michigan being important to maintaining that mesolow circulation. And I think that's really highlighted with the Channel 5 snow ice band here. And I want to give credit to Jim Ledoux for a write-up on his blog on this event, which really highlighted this process where using the different refractive properties of water and ice here, with ice being a stronger absorber in this channel 5 band, you can see the transition in this loop from bright whites here to darker shadings, kind of indicating that glaciation process occurring over as the mesolobe moved inland here with that convection. So you can see, kind of run this one more time here, how you had these really intense convective cores near the circulation center, but you can see that change to more of a darker appearance on the imagery, indicating a change of phase with this channel 5 imagery. So I think that's another testament to the role of latent heat release, that it was probably a big player in this scenario. So just wrapping things up here, operational considerations. This really posed a headache for our office there in northern Indiana, as this radar imagery here is from the morning before it made, so we're looking about 8 hours before the mesovortex moves inland. We were dealing with a dominant single band out ahead of this mesovortex. And we had winter storm warnings out for Berrien County there in southwest lower Michigan, surrounded by winter weather advisories. But you can see as we got toward 13Z on this morning here, you can see on the northern periphery of this radar image, these west-east bands here, that was the southern periphery of that mesovortex dropping south, and low-level winds likely here back westerly, kind of cutting off our better fetch for this lake effect snow. And it kind of destroyed the snow potential for Berrien County through the day on New Year's Eve. So we were kind of in a tough situation. We didn't know whether to continue the warning for Berrien County with this big lull between this time and the mesovortex. And there were indications in the high resolution runs through the day that this mesolobe would have a longer duration time over Lake Michigan, which would effectively shift that dominant single band to the west back westward here. And so we were concerned that LaPorte County would have greater impacts than Berrien County. So then you have to weigh the effects. Do you expand the warning westward? We did end up eventually putting LaPorte into a winter storm warning, but these are almost like short-term convective warnings. Any one area will be impacted for 2 to 3 hours, and then that's it. So it's almost like a different time scale you're dealing with compared to your normal lake effect headlines. So that's pretty much all I had. Just quickly reviewing here, talked about how both the fluxes and the latent heat release were important. Obviously, the lake fluxes are primary, and then the latent heat release is a second additive effect to that, but not inconsequential. I think that diabatic PV anomaly was definitely the big player in Lake Superior developing the large-scale mesovortex. And also, both of those combined for a slower and longer residence time over Lake Michigan, which allowed that dominant single band to shift westward more than earlier indications were suggesting. And I think one of the challenges going forward with this PV perspective and looking at the effects of latent heat release is that it's kind of easier to do after the fact, but it's harder to assess the role of that latent heat release in real time. I know there's been a lot of studies on PV inversion, which is a good way to quantify how much does this diabatic PV anomaly communicate to the upper levels and lower levels. And the challenge is always how to bring that into the operational environment. And then finally, just a way to look at the magnitude of the fluxes, is that because I think once you get into that 600 to 700 watts per meter squared, it just should be kind of a flag that, hey, this is an environment that could be supportive for these mesovortices. So that's pretty much all I had, and we can open it up for questions here.
Thanks, Nathan. That was awesome. I didn't realize when we scheduled that you were coming off a midnight shift, so thank you for staying awake. There was one question submitted from Doug Wesley up in Alaska, and it's about the latent heat release. Is that mostly, what could you tell from the model simulations? Is that mostly from the formation of the stratus to stratocumulus, or is it from precipitation growth in the crystals and droplets? Is that something that you were able to look at in the model simulation, or do you have a feel for that?
I don't really have a great feel for that. My suspicion is that most of it was due to the more intense convective cores, but that would take more looking into, but I think it is related more, maybe probably in this case, to the actual convective precip. That would be just a hypothesis, not completely sure on that.
Thanks. And I just have a comment because from a satellite perspective, I see these kind of things fairly frequently, but this one was unusual. It seemed it had so much tropospheric support. So in addition to the very cold air to get the big fluxes, you had some kind of potential vorticity forcing from some baroclinic forcing with it, which sometimes when you see these smaller scale events that look similar, there are still these nice mesovortices. You don't necessarily have the baroclinic features, just strictly driven by latent heating. So this is an interesting case from that. Another question. That was just how did the HER and RAP do with this event? That's from Brian.
Okay.
I think you mentioned pretty well forecast.
Yeah, when we talked about handled well numerical from a numerical modeling perspective a couple days in advance, it was handled very well in terms of the Lake Superior portion of the event. There was some indications of that mesolow pretty much within a 30-mile either way near Marquette 2 to 3 days in advance. But as it became the Lake Michigan part of the event, it was there was a tendency to I think underestimate the strength of the circulation a little bit and bring it inland a little too quickly, and thus it looked like the heavy snow band would be more in our southwest lower Michigan counties the night before, whereas through time, especially it seemed like late morning, the 16Z run or 15Z run of the HER, it really started to latch on to that westward shift, and that's kind of that's when we started to nudge the forecast back to the west when the HER started going that direction.
Sorry, I was muted. Another question here. There are now snow squall warnings. Do you think this kind of event would lend itself to a snow squall warning?
That is a very, very good question. It's something we are in constant collaboration with our surrounding Great Lakes offices with. There's different philosophies on the snow squall warning with lake effect. There's one train of thought that if these mesovortices tend to create heavy snow breaking away from your typical lake effect snow band area, that for example, this mesovortice pushed inland far enough that it was producing these type of conditions in a county not under a current headline, that would probably be a trigger point for a snow squall warning. I think most offices are kind of under the assumption to not issue them for lake effect unless it's kind of these breakaway type situations where it moves away from a typical area. But it's a good question because this is not a typical lake effect snow band. It's definitely something we need to talk about more.
Do you know if either Marquette, I mean, you are in a default mesoscale domain. So I'm assuming this time of year you probably have the default 1-minute imagery. Do you know if Marquette requested a mesoscale domain up over Lake Superior when this was dropping down? Or did you do it just to make sure that the domain stayed over you?
That is a good question. I'm not sure about. I apologize for that. Yeah. We had our local we had an issue with our local storage, but didn't capture all the data for this event. So that was one reason we kind of had to go to other sources to kind of supplement the data here.
Okay. I see that we're after 12:30, so I want to give you time to unwind. So there were a couple more questions on here, but for the interest of time, I think we're gonna call this an end. I really appreciate the time you gave for this talk. It was very complete, and I was impressed by it. And I think your colleagues on the call are also appreciative. So
No, thanks for the opportunity to present this. Appreciate it.
Thanks.
Thank you.